Should I read? Can you just go over how to solve this?
Yes. Can you
Yeah,
tell
I
me
can-
which one it is?
Yeah. So the absolute value stuff. You want me to read the question?
Oh, I have this supplement here.
Yeah. It's last page of the supplement, number 8.
So we're talking about this one?
Yes.
Okay. What was the problem with this after you, I'm assuming you did the one in class. That we did in class.
Yeah.
Okay, so let's take a look then. So 9 minus x plus the absolute value of 3x minus 5. So as we did last time, we have to simplify each and every one of... Oh, I didn't ask you, did you have any questions on the classwork from last time? Is there anything, do you understand your mistakes? Any questions on that? On the classwork from last time? Okay, any questions? So just remember the agreement. That will follow us everywhere we go. That's why I did that on the first day of classes, so we can say, I've got this under my belt. It's done. The other thing that I would do, if you remember, I keep repeating myself, and I will repeat myself all the time, as I do in all my classes. A little notebook will be very useful, in which I will also write the new information, but I will also say, maybe second half, I know how to solve linear equations. Check. I know how to solve quadratic equations. Check. So first half, maybe you want to put the new information that you have to acquire in time, and then the second half, what you already know. So that will really be helpful to you, so you know where you are, where you stand. I know how to simplify absolute value expressions, and this is the formal definition, and now I already know how to do it. So slowly you move the concept from the front of the notebook to the back or to the second half of the notebook. Does it make sense? Or you can say, I'm not interested in your pep talk. I have my own game plan that works, and that's fine. Stick with your your own game plan, as long as it's taking us where we are going. Okay, so then the first step will be the 9 minus x in absolute value, and you remember the definition. It's this if this is greater than or equal to 0, and it's negative itself if it's less than 0, right? So I have to 9 minus x if 9 minus x is greater than or equal to 0, or the opposite of 9 minus x if 9 minus x is less than 0. So this is the starting point in all cases. There is no change here. There is no new stuff. So of course I have to solve this inequality, and I move 9 to the other side, negative x greater equal to negative 9, and then what do I have to do? I have to divide or multiply. In this case, both work. Divide or multiply by both sides by negative 1. So that makes x a 9, but I have to remember something extremely important that says yes, of course. So I refuse to solve this one. So if the first one is x less than or equal to 9, then the second one must be, that's it. There's no other way. I repeat for 3x minus 5. 3x minus 5 is 3x minus 5 if 3x minus 5 is greater than or equal to 0, or negative 3x minus 5 if 3x minus 5 is less than 0. Of course, I have to solve the first inequality. What do I get?
Greater than or equal to 5.
Awesome. I refuse. Don't do that. I'm just making a point, trying to trigger something in your memory. So what is the second one then? Right. I recommend this chart that summarizes all the information. If you have a different method that works, forget about mine. It's fine. I'm okay with that. So the absolute value of 9 minus x, the absolute value of 3x minus 5. And the last row, of course, is what I'm interested in to simplify the whole thing. So the absolute value of 9 minus x plus the absolute value of 3x minus 5. X has to be the first row because x represents values of the variable. So x can be what? There are no restrictions for x. X can be anywhere between negative infinity and infinity. But specifically, which values do we need in the chart? We do need 9 and they have to be in ascending order. Which one do I put first? Very good. So it's 5/3 and 9. Now I will summarize the information and copy it in here where it belongs. I will take this information and copy it here where it belongs. So can anyone dictate that? What should I write? What do I write in the first subinterval for the first absolute value? Of course. What do I write in the second subinterval for the first absolute value? Of course. Now, let's stop for a moment. Do we understand why? I just read what I see. The absolute value can be replaced by 9 minus x for x less than or equal to 9. 9 minus x. The absolute value is replaced by negative 9 minus x, or if you want x minus 9, for greater than 9. I just take the information I have and put it in the chart by reading it. Is this better? Nico, is this okay?
That's the chart. Yeah, I understand like the solving the inequalities.
The absolute value of 9 minus x equals 9 minus x when x is less than or equal to 9. 9 is here, less than 9 is here, so I have in this row, I replace this. For x less than or equal to 9. For greater than 9, I have this equals this. For x greater than 9, I have x minus 9. I only take this information from here and put it here. Is that better somewhat?
Sure.
So how will I write the second one then? Between these two, what will I write for this? What can I replace it by? Right. Negative 3x, you're right, plus 5. I want to eliminate parentheses. Awesome. What do I write between 5/3 and 9 for the same one?
3x.
Right. And between 9 and infinity, what do I write?
3x.
Right. Is that better? It's just reading it carefully and finding where it belongs. Why? Because it's so much easier now to look at 3 different situations instead of trying to mix and match. That will be more difficult. Very good. And now what operation do I perform? Adding. All I have to do is add these terms, like terms. I add negative 3x to negative x, and I get negative 4x. I add these two, and I get 14. And this is done. I add here, and I get 2x plus 4, and this is done. Because 3x minus x is 2x, 9 plus minus 5 is 4. Here I have 4x minus 14. Only because this is plus. If it were a minus, like we had last time, I had to be careful, distribute the negative to the second one. But here it was only addition. So I only added like terms. Now the final simplified form has 3 options. It has negative 4x plus 14, it has 2x plus 4, or 4x minus 14, if. So I have to write 9 minus x plus the absolute value of 3x minus 5. I'm just copying it. Now I have to, remember I have to put the equal symbol in only one of the 5/3 and 9. It doesn't matter how you write it. So this is for this interval. This is for this interval, and this is for this interval. So for the first one, I write x less than or equal to 5/3. Or put the equal symbol in the next one. It doesn't matter. But not in both. So if I have the equal symbol here, I cannot have it here. If I have it here, I cannot have it here. You can put them both in the middle part. It doesn't matter. This is a continuous function. You'll see later in calculus what it means. So it doesn't matter where you put the equal symbol. Very good. Good question. Anything else? Is there anything else you worked on that you need help with, that you would like to ask, or anything? Anything else? Okay, so let's look at absolute value inequalities. Nico, did you have something else?
Yeah.
So is this okay now? Better?
Better.
Okay, very good. So absolute value inequalities, I'm going to make one up. Let's say 2x minus 3 is less than or equal, the absolute value is less than or equal to 3. And that's one example. And let's say x plus 2 is greater than or equal to 4. These are two different types. Now, the first type, again, trying to understand what it is and what it's asking us to do is more important than just memorizing stuff or writing it down without understanding it, I think. So, what does this say to me? This one says this. Find numbers whose distance from 0 is 3 or less. Whatever these numbers are, I don't care. But I'm looking for numbers whose distance from 0 is less than or equal to 3 or less. So imagine the real line. Where will I find those numbers with a distance from 0, 3 or less?
Between -3 and 3.
Of course, that's very clear. Exactly. So they have to be here. 3 or -3 or closer to 0. So this is exactly all we have to remember and nothing else. So this one changes into 2x minus 3 less than or equal to 3, greater than or equal to -3. Exactly what you just said. Once we understood what he was asking us to find, we knew how we understood or remembered or we learned, if you want, right now, how to convert it. So remember, you cannot touch this. If it has a 2 in front, you're not allowed to plug it in, to distribute it. If it's 1/2, you cannot distribute it. You cannot take anything outside and say, okay, I'm going to factor. Absolute value is a totally different situation. It's not a grouping symbol. You can't touch it. You cannot break the absolute value. But what you can do is change this into this. Solving this is like solving that. And this we know how to solve. This is a compound inequality. What do I do to solve for x? First step. I have to eliminate the weakest link. What is the weakest link? Yes, I'm adding 3 to all 3 sides. Very good. So this is 0, this is 2x, and this is 6. I'm adding 3 to all 3 sides. And now I have to remove the last link, which is dividing all 3 sides by 2. So I have 0 less than or equal to x less than or equal to 3. In interval notation, how do I write this? So this is x in the interval.
Bracket 0, 3.
Awesome. Now let's go back to the other one. That's the reason why when I present this, I always present them side by side. What does this say? This is a totally different situation. This one says find these numbers whose distance from 0 is 4 or more. 4 or more means this or that. Nothing in between. You cannot include anything in between. That is taken by another inequality. So when I solve the inequality, the absolute value of x plus 2 greater than or equal to 4, I cannot write it as a chain. Not possible. So this is totally changes into two totally different inequalities. One of them is x plus 2 okay, which tells me that it's not clear. Okay, so this is -4 and this is +4. This time we want to determine values of x that make that expression be, or the number be, further away from 0 than 4 and -4.
So x plus 2 less than or equal to -4.
Exactly, to that side, yes. Or x plus 2 greater than or equal to, that's it. You have to be very careful not to include anything between -4 and 4 because that is already taken by this inequality. Very good. So now I solve this, x less than or equal to -6, and I solve this by subtracting 2, and this is 2. The solution for this one will always have the union symbol in between. And we start from left to right. Which inequality will you write first?
Small silver.
Of course.
-6 with bracket.
Very good. This is it. -∞ to -6. Union?
Bracket 2
Of course, the second type of inequality is slightly more difficult than the first one because, first of all, I have to separate it into two different inequalities, and I could not solve them in a chain, and that would be a terrible mistake to make that attempt. So these are absolute value inequalities. Questions for me, please? Questions?
One easy way to
Yes.
remember them is the less than. If you're looking at the original inequality, if it's the less than sign, it looks like a C, so it's a conjunction. So you know it's going to be
An intersection, in other words.
Right.
Yes.
And then
The other
greater
one
than
would be
sign
the
looks like a D, so it's like a disjunction.
The union. Awesome. Very good. Okay, I want to refresh before we start chapter 2. I want to refresh your memory a little bit on midpoint distance and lines. And we'll look at a word problem, and then we can move on to chapter 2. Okay. So this is 1.8. Distance between points and midpoint. Okay, so I'm going to draw 2 points or plot 2 points on a coordinate system, and here they are. I'm going to call this point A. I'm going to call this point B. And I would like to determine the distance between the two. Again, in your notebook, if you start creating something like this, I would identify what the distance is and how to, what is the formula for the distance, and so on and so forth. Okay, so I'm going to call this x1 and this y1. So the coordinates of A are x1 comma y1. I'm going to call this x2 and this y2. So the coordinates of B are, since B is the second point, I'm going to say x2, y2. In order to find the distance between the 2 points, I'm going to form a right triangle with a 90-degree angle, of course. And if I manage to determine this leg somehow, and this leg, I'm going to call it leg 1 and leg 2, assuming I manage to determine the measurements of leg 1 and leg 2, can anyone give us a theorem that is applicable in all right triangles? It means nothing because I don't know which A, what is A, what is B, and what is C.
Leg 1 squared
Awesome. Yes, I agree. Leg 1 squared plus leg 2 squared equals the hypotenuse squared. Awesome. That is perfect. Thank you. Good. So now I'm trying to see if I can find this leg, the measure of this leg, and if there is a way of finding the measure of that leg. Can anyone come up with an idea for the measure of leg 1?
It's 2 minus x1.
Very good. So it's this distance, which is x2, minus this distance, which is x1. Perfect. So x2 minus x1. Awesome. So what is the measure of the other leg then? Perfect. y2 minus y1. All I have to do is plug them in the formula. And I will start with d squared. So d squared equals x2 minus x1, everything squared, plus y2 minus y1, everything squared. This is good, but it's not good enough because I need to find d. What do I do to find d? Take the square root from the left and the square root from the right. When we take square roots from both sides, we have to write plus or minus, right, for two solutions. However, because this is a distance, here I cannot write plus or minus. So this will be d equals, can I simplify this in any way, shape, or form? The answer is correct. We cannot. Very good. x2 minus x1 squared plus y2 minus y1 squared. This is it. The square root of a plus b does not equal the square root of a plus the square root of b. You did not fall into my trap. Thank you. Awesome. Okay? The square root of a sum does not equal the square root of, or the sum of the square roots. And we know this from here. We reviewed this last time. How come that we did not take the square root of 1 plus the square root of this? Because we can't. We cannot break the radical into two radicals if the radicand is a sum or a difference. Bless you. We can break it if it's a product. We can break it if it's a ratio, but not if it's a sum or a difference. That's why we never did that here, right? So this is the distance formula. That's how we remember it, and it's done. So that's distance formula. We'll pick 2 points in a minute and we'll illustrate the distance and the midpoint. So let me talk about the midpoint. The point that divides the segment into two equal parts, normally denoted by uppercase M. So this segment is half of the distance or equals this segment. It's called the midpoint. So the coordinates of the midpoint are the averages of x, comma, the averages of y. So I have x1 and x2. How do I determine the average?
Add them and divide by 2.
That's it. x1 plus x2 over 2. I have y1 and I have y2. How do I get the average? The same. y1 plus y2 over 2. Okay, so now let's pick 2 ordered pairs, any ordered pairs you feel like practicing with, and let's illustrate how to find the distance and the midpoint. Whatever you give, also put some negatives in there.
Negative 2 and 3. 1 and 7.
Perfect. So the easiest thing to do is just finish up the midpoint right away. Please add up the x's. When you add up the x's, you get how much? Of course. So it's negative 1/2 because it's the average. So please add up the y's. 5. So this is the midpoint. So if I plot the 2 points and I connect them with a line segment, then the point negative 1/2 comma 5 will be exactly in the middle of that segment. Okay, and now all we want to do is find the distance. Again, I recommend this method, which I think it helps you, prevent you from making mistakes. However, I accept other methods as well. So here's what I like to do. I write the formula, I copy the formula, and underneath every x1, y1, and so on and so forth, I write the values. So this is my x2, so I write 1 underneath. This is my x1, so I write -2 underneath. This is my y2, and this is my y1. That also prevents me from writing it one more time. But again, it's up to you what you want to do. So now let's work on this together. 1 minus -2. What is that?
3.
How much is 3 squared?
9.
So this is square root of 9 plus. 7 minus 3.
4.
4 squared. Awesome. So now the distance is the square root of, awesome. Therefore, the distance is perfect. Great job. Any questions for me? Okay, I would like to go to the last section of this chapter and review lines and look at a word problem. Maybe graphing if you need to, and other problems. So we can start chapter 2. Okay, so 110, lines. What do we know about lines? Yes, yes. So first of all, they can look like this. Paul, say it again.
Oh, I didn't realize we were. Is that 1:10?
1.10. The last section of chapter 1. There are 4 different types of lines. What type of line is this? Right, and this one? Right. And these are both not horizontal, not vertical. One of them looks like this. What kind of slope is this?
Positive.
And the other one looks like this. What type of slope is it? Like a trend, if you want? Right. What about the slope of this line? Right. What about the slope of this line? Awesome. Undefined. There is no slope. For a vertical line, there is no slope. You have a question? Okay, perfect. So that's one thing that we know. The other thing that we know also, parallel lines So what do we know about parallel lines? Very good. M1 equals M2. This is M1, this is M2. They have to be the same. Okay, now let's say I have 2 lines that are perpendicular. They form, if you want, 4 90-degree angles. So this is M1, and this is my M2. Perpendicular. Okay. What do we know about the relationship of the negative? So one way would be, this is how I like to remember it. M1 times M2 equals -1. But it's the same thing with saying M1 equals the opposite of the reciprocal of the other. It's up to you. Here I cross multiply and I get this. Same thing. I prefer this myself. You choose. Now we also have 2 equations. You can say 3, but one of them is not useful. But we can say 3. 3 types of equations. One of them is y equals mx plus b. The other one y minus y1 equals the slope times x minus x1. And the other one that is not useful is ax plus by plus c equals 0. This is the slope intercept form. This is the point slope form. And this is what is called standard. Not useful. Because I have to solve it to find the slope. I have to solve it for y to find the y-intercept. It's not really useful. And the slope of a line going through 2 points is? Yes? Which is? Difference in what?
And y over difference.
Yes, difference in y over difference in x. Good. So, I'm looking at your book and I'm trying to yes, why not? 72. 72 on page 117. Depreciation. A small business buys a computer for $4,000. After 4 years, the value of it is expected to be $200. For accounting purposes, the business uses linear depreciation to assess the value of the computer at a given time. This means that if v is the value of the computer at time t, then a linear equation is used to relate v and t. Find the linear equation, sketch the graph, what do the slope and the y-intercept represent, and find the depreciated value of the computer 3 years from the date of purchase. Okay, so let's start from the beginning again. It says a small business buys a computer, so this is 72 on page 117. For $4,000. After 4 years, the value of the computer is $200. First question. We are told that v is the value. So this is the value, the initial value. And this is the value later, but also value, and the time t. So we are asked to use v and t to find the linear equation because we are specifically told that depreciation is considered linear. If I don't have that information, I'll say, I don't know what to do. You haven't told me the trend. You just threw some numbers at me, but if you don't tell me what the trend is, I'm not going to be able to figure it out because I only have 2 pieces of information. So, but we are told, for the purpose, it says, for the accounting purposes, the business uses linear depreciation to assess the value. So, what is given in this problem?
The y-intercept of 1.
True. That's correct. But furthermore, how do I write what I'm given? Perfect. You're on the right track. I'm very happy with the answer. But how do I write?
0, 4,000.
Awesome. Do you all agree with 0, 4,000? The initial value means when the computer is brand new, it's not old, it hasn't aged yet, 0, 4,000. We all agree with this? Okay, perfect. What other piece of information we have?
4,
4, 200, indeed. So notice one thing that we always have to think and remember. This is the coordinate system. This must be the independent variable, and this must be the dependent variable. We have here value and time. Which one must be the independent variable? No question. Time. Time is the independent variable. And which one is the dependent variable?
The value.
The value. Awesome. Thank you. So then, what I'm told that I'm given actually 2 points, and I'm asked to find the linear function, which is v of t, right? V of t. This is the y, and this is the x. Perfect. So this is what I am asked to find first. How do I do this? Knowing that it has to be linear. Awesome. I must find the slope. Can anyone dictate what I use and how I use it when I find the slope?
Right over run.
Right?
We use 200 as 1,000, 200.
What slope what kind of slope? We have 3 possibilities, right? Positive, negative, 0, or undefined. What kind of slope do you expect to get? So that's another idea for your notebook if you're starting something like that. Exactly. Because why? We're talking about depreciation. Okay, perfect. So then the top is negative 3,800 and the bottom is 4. And what do I get? Minus 9. That's 50. Okay, now, if I just write minus 950, I can't get full credit. Why? What am I missing?
You need to know the value of the computer rate.
What am I missing?
950 over 1.
Right? What else?
Units.
Exactly. Without the measurement unit, this means nothing. Nothing. So the measurement unit for the slope must be a ratio of 2 measurement units. One coming from the top and one coming from the bottom.
Value of 10.
So what is the value measured in?
Dollars.
What is the time measured in?
Years.
So this is the correct answer. Dollars per year. Which per year? Which means a lot. Which means what? It means that the value of the computer we pay today, $4,000, and we have to remember that every year that passes, the value of the computer decreases by $950 per year. Yes. So without the measurement unit, this means nothing. Okay, perfect. So now I have the slope, and as Cheyenne noticed, this is the y-intercept. Knowing that I have the y-intercept and the slope, I will not go with this. Will I get the same answer if I go with this? Yes. But this is easier. Okay, so how do I write the equation then? V of t equals?
Negative 950 t plus 4,000.
Perfect. Thank you, Joey. Very good. Excellent. And now, after we found the equation, part B, it says sketch the graph. We will do that in a minute. What do the slope and v-intercept of the graph represent? We already talked about the slope. What does the slope represent? The amount of money that the computer depreciates by every year. Okay. What does the y-intercept represent? We also know that.
Initial value.
The initial value of the computer. Awesome. And final question here before we graph it. In a minute we'll graph it. Find the depreciated value of the computer 3 years from the date of purchase. What do I have to find?
Okay, so that's 3 for each.
That's it. So negative 950 times 3 plus 4,000. When you have this number, I'll put it in. And then I would like to graph this function. Thank you very much. And this is dollars. Good. So now, I already have more than I need. I have actually 3 points, right? I have the point 0, 4,000. I have the point 4, 200. And I also have the point from here. Which point?
350.
That's more than I need. So I would like to find when the value of the computer is 0. What do I have to do in order to find when the value of the computer is 0?
Graph it from the smallest.
No, I already have the function.
Put
Huh.
0 on the left side and solve.
Exactly. When the value is 0, I have to solve for t. How long it takes for the computer to be worth nothing. So let's do that. Always remember when we're asked to graph, domain, that's another thing for the notebook. Always when I'm asked to graph, I look at the domain, mandatory. That's the first thing. There is no discussion of domain here. It's time, so it must be 0 to infinity, right? There's no negative number. The second thing is the x-intercept, if it exists. And the third is the y-intercept, if it exists. For any function, ever, domain, x and y-intercept. Good. So I'll find 0 equals negative 950 t plus 4,000. So t equals 4,000 divided by 950. What do we get?
Around 4.21.
4.21 approximately? Okay. So 1, 2, 3, 4. So we will cross somewhere here. Then I have 0, 4,000. I'm going to say 1,000, 2, 3, 4. So this is the V of t in dollars, and this is time in years. 1,000, 2,000, 3,000. That's all I need. I don't even need to plot that point. So I have the x-intercept, and I have the y-intercept. And here's the graph. When I graph a function, I always write somewhere next to the graph what I graphed. And this is the graph of negative 950 t plus 4,000. Any questions? Okay, with the graphing calculator, because we are going to use it, so I will plug in, of course, negative 950. There is no t. We have to use x in the graphing calculator, and plus 4,000. And I will go to the viewing window. I don't want the calculator to graph whatever. So I'm going to say x cannot be more, okay, cannot be less than 0. The x maximum, I already have the answer. I'm going to say 6, although I know it's going to cross at 4 point something. The scale for 1, it's good. The y minimum, of course, we're not talking about a negative value, so it has to be 0. Y maximum, however, has to be 4,000 or more. I'm going to put 4,500 with a scale of 500. And then press graph. And here's my graph. It starts at 4,000, crosses tiny little bit beyond 4, and I can plug in any number I want. I go to second and table. And now we had 3. Oh, it resets all the time. Okay, I have to go to second and table set, sorry. So the independent variable, only the independent variable has to be in the ask mode, so press enter. So now it allows me to plug in whatever I want. So I'm going to plug in 3, and I would get 1150. If I plug in 2, I'll get whatever, 2100, and so on and so forth. Any help is needed with the calculator? Are we okay? Nico, are you okay?
Yeah.
You need any help with that?
No, I just missed the step to do the table.
Go to second and table set. So second and table set, and we have to check. Yes, independent in the ask mode, so the calculator allows you to plug in the numbers you want. And then we go back to second table. And you plug in whatever you want. 0, 1, 2. Okay. Any questions? I want to work on one more problem and then we continue. Chapter 2. Something like 35 on page 116. We're asked to find a line that is going through a point, passing through -1, -2, and is perpendicular to the line 2x plus 5y plus 8 equals 0. 2x plus 5y plus 8 equals 0.
What's the first one?
So this line passes through this point and is perpendicular. That's the symbol for perpendicular. I was lazy. Sorry about that. To this line. So here's the idea. Let me make sure I don't pass the